everyone. My name is Matthew McDole. I'm an engineering leader for Yum. Really quick, what is Yum? Yum owns Pizza Hut, KFC, Taco Bell, and Habit Burger Grill. We're one of the world's largest quick service restaurant companies in the world. We operate in 155 countries and we have over 50,000 locations worldwide. I'm the engineering leader for two internal platforms. One is called the Commerce Platform and the other one is the Menu Management Platform. We're not very creative namers at Yum. And Temporal is becoming an increasingly important part of both of these platforms. So last year we shipped KFC and KFC came on board our Yum Commerce Platform, and whenever they did, every KFC order became a temporal workflow. And it orchestrates the order end to end. This past year, we've been focusing on Taco Bell, and Taco Bell shipped on the Yum Commerce Platform in Q1 of this past year. So now every KFC and every Taco Bell order, if you order it online, is flowing through the Yum Commerce Platform. And it's now actually two workflows, not one, because we do payment settlements with Temporal as well, but we'll get to that. And then through the rest of this year and into next year, we're focusing on Pizza Hut. So we've brought Pizza Hut Peru on, but we have not gotten Pizza Hut US, and it's our big project that we're working on right now. We sort of split up our platform into domains, and these are some of the domains in the Yum platform. And Temporal has been spreading across these domains. So we started with order, but now the menu and store domain has a critical Temporal component. The payment domain has a critical component in it that's run by Temporal, and now the cart domain also has Temporal workflows. So, let's see here. Oh, the promotions domain also, we have a new use case that we're working on. It's not out yet, but it'll be coming up soon. So a question that a lot of people ask is, how long did it take your teams to deploy your workflow, get it from start to finish kind of into production, or at least complete its development? And for us, it took the order domain about 6 months to get off the ground. Now, we did have some starts and stops for its deployment, but that was unrelated to the Temporal development at all. It took the menu team about 4 months to build their menu publishing workflow in Temporal. It took the payment team 2 months to switch our payment settlements over to Temporal. And it took the cart team 3 months to do our cart abandonment workflows in Temporal. I definitely think it's accelerating. We have a growing stable of people internally with Temporal expertise, and they help each other. We have our internal Slack channels that, as we're standing up new use cases, we can rapidly deploy those people to help the new pod. So the talk for today, what I want to convey is, whenever we were starting, we were hungry for real-world use cases and real-world examples of how a company composed their workflows and activities. The examples are great and the documentation is great, but seeing how people actually deploy it and the engineering trade-offs and decisions that they make were something that we very much wanted to see. So today, I'm going to be stepping through all 4 domains that is used inside Yum Brands for Temporal. I am going to go in deep on the workflow design. I'm going to show you every activity, every workflow that we have and how it flows. And then if there's any lessons learned that those teams sort of have, I'll sort of bubble those up. And we also internally had an AI art contest with a Yum theme. So those are my transition slides. So this is one of them. This is the kernel. So we're going to start with order. Order is our transactional flow end to end. If you're placing an order, it has 15, 16, 17 steps, and the order workflow is what orchestrates that from start to finish. And whenever we spoke last year, what we were really kind of speaking from was a position of we're deciding how to use Temporal, should we use it? Should we do internal hosted or cloud? And, how do we safely deploy it against our legacy system? And then also, what is the state of our world pre and post Temporal with our deployables? That's not the focus of our talk. This year, we're all in on Temporal now. It's no longer about a decision anymore. We're bought in, and now it's just sort of organically spreading throughout the company. So the order use case, just as for a quick recap, is this. If you're going and you're placing orders on any of the digital properties for Taco Bell, KFC, and in the future Pizza Hut, that in the background, the entire order will be orchestrated by this workflow. So let's look at what the workflow design is for order. This is the shape of our order workflow as I sort of see it. And I'm going to zoom in there, so don't stress out. But the red blocks are timers, the green ones are activities, and the yellow blocks are signals. And this is sort of how I think of our order workflow. And if we zoom in here, the order workflow gets kicked off, and we do a payment authorization activity. We fetch the customer's current cart. We'll persist the order to the database. We will then emit an order created event. And then we will start to redeem any promotions that are associated with the order. After that, if there's any loyalty rewards associated with the order, we'll then redeem those. And then we'll reset the customer's cart. And then after that, we transmit the order. We're transmitting it down into the store. So these first set of steps that I've just described is sort of an automatic and sequential set of steps that occur. From this point forward, our workflow is now asynchronous. So the order is going to be concluded by being driven by a set of either signals or timers firing. So there's no more automatic execution from this point forward. We're waiting on these things to occur. And the first one that we're waiting on in a happy path flow is we're going to get confirmation from the store that they have the order. Then we have an activity for that and an event activity for that. Then we're waiting for confirmation from the store that they are committing to making the food. So they've started to make it. So we've got an activity for that and a signal activity for that. Then we have a signal for the food is now ready. It's been prepared, it's ready to go. And this will advance those same two sort of like activities. And then finally fulfill, meaning the food has been handed out to the customer or to a delivery driver, and we consider that order fulfilled. Once that happens, now we get back into the automatic execution, which is we have a payment capture activity that fires, so we can capture the payment before we were just authorizing it. We close the order, and then we have a final event activity that signals within our internal Kafka system that this order has been concluded. So that's the happy path for the order. The non-happy path is this. So we have three ways that an order can fail. It can either be canceled, it can be rejected, or it can be failed. And those have different business connotations within our system. But if it either those signals come in externally or if it fails internally for a reason, they all kind of flow through those same code paths. And then we have a set of compensating transactions that run to recover promotions, loyalty rewards, and things like that, and devoid the payment auth. So order, like the first lesson that I want to describe that we've learned, and actually let me get a drink here really quickly. The first lesson that we've learned, I think, is whenever we first created this workflow and we got it into production for KFC, the first half of our workflow I felt like was very understandable and easy to understand, but the back half of it became a little bit complex for us. And this past year, I feel like we've cleaned up a lot of that, and I feel like the whole thing is easy to understand, but I just want to articulate what we did and then what we did to fix it really quickly. Okay, so whenever we started building our first workflow, this was the best example that we found that Temporal had out there. And this is the background check example. And Rob Holland created, I don't know if Rob is here, but yep, there he is. Amazing example. And what this is it walks through like a company I think like Checker that would do like a background check on an applicant. And it has some meat to it. That's what we were looking for. It has child workflows. It has signals come in from a person interacting with an application kind of thing, similar to kind of what we have in our order situation. So we studied this in great detail. And I'm actually going to just walk through the workflow definition function because it's like you'll understand how it works really quickly. So it creates sort of this wrapper struct that maintains the state for the execution. It sets up a query handler, and then we just go through these steps. Like the first step, I think, is it emails the candidate asking them to accept the background check. And if they don't, then it's going to email the hiring manager that they did not accept the background check, and then it ends the workflow. If they do, it kicks off a social security trace. And then after that, if that failed, it's going to email the hiring manager, hey, this failed. If it passed, it's then going to start to initiate a set of background checks. So it's going to always do this federal background check, but there's other ones that are conditional depending on the size of the background check, if it's like a full background check or not. So it'll do the state, it'll do the auto, and the employment verification. Then it has like an await to wait for all of those things to finish, and we'll send the final report. So our code for our order workflow definition is very similar. So this is at like a high level, where here we're authorizing the payment, we are fetching the cart, we're redeeming loyalty, we're saving the order to the database, we are doing the promotions, we're resetting the customer's cart, and then we're transmitting the order down into the store. So up till here, we're fine. But our workflow has all these competing asynchronous concerns. We've got all these timers, and we have all these signals. And I'll say that like the way that we handled these in our first pass wasn't great. And what we did was I think we sort of had fat handlers for these, where we were actually implementing the logic for what should happen if one of these things should occur within the handlers themselves. And it made our sort of workload go from like looking like this to like trying to understand it to looking like this. Whenever it was executing, we would have things where, we'd have signals coming in, but we were already currently, processing something else. It took us a little bit to figure out what to do here. And we asked the temporal team for help, and this was their recommendation, that we should funnel all those competing concerns that we have for these asynchronous things into a single workflow.await. So here is what we do now. If we create a timer for this workflow, all that we do in our timer for this workflow is we set a Boolean to true. That's it. We've ripped out all of the code that was inside these timers. We do the same thing whenever signals come in. This isn't truly a Boolean. It's like a couple Booleans and like a reason and a client ID, but just pretend that that's a Boolean. And now what we do, with our funneling all these concerns, you'll see that we have that transmit at the top, and then we have this await, and the await is just waiting for one of these conditions to be true. So it's blocking. So we get back to sort of our procedural blocking code that we liked and was so simple to understand. And then we have like just a function that will run that goes through a switch statement that's like, okay, which of these things was true? And then we get to define the order that we want to take care of them in here. And this got us back to how we wanted to be. And we do the same thing down below in an infinite loop. And then that's just because we sort of had to separate sort of pending orders from post-pending, but we have all of those, that commit, ready, fulfill, they're just happening over and over. And then whenever they hit a terminal state, this will break out and then we'll end the workflow. So this cleaned things up for us a lot. The next thing I want to talk about in the order domain is something I'll call like fearless features. So whenever Taco Bell was coming on board, a problem that we had was breakfast. We didn't support day part menus, and a big thing that they have is if you place a breakfast order on the Taco Bell system, breakfast obviously ends at some point. And what Taco Bell wanted, the requirements were that we would automatically cancel an order if we exceeded that sort of breakfast time threshold, and they also wanted to warn the user ahead of time that like, hey, your order is going to be canceled if you don't come get your breakfast item. So this is what that looks like in reality. So on the left, you'll see like you'll get a text message saying that, hey, this isn't going to be available anymore. And if you do nothing, you'll get the thing on the right. So I think sometimes it's instructive to think about how we would have built this before. And this is like our old order deployable components for our old V1 system. And then we eventually switched to the temporal thing and we got rid of all these things. But if we had to build this feature, before we came on temporal, at a minimum, we would probably need to create like a new daypart poller, right? That is like polling the database and finding these orders that are exceeding these thresholds. And then I don't even want to get into the state machine changes that we would have to make to support this. So this would not be fun. But in temporal land for us now, this feature is super simple. It is literally 2 timers, and they just kick off event activities and conditionally cancel if they're configured to. And I still remember our product owner, as we were describing the development for it, they were really worried about us getting this into Q4. And it was like, okay, we were done. We were done in one day. The development for this feature took one day. So I think the feeling that I want to describe a little bit is, I can't tell you the number of times that I'm sitting in meetings listening to our business users describe these business needs that they have, and the problems they're presenting actually without durable execution or durable timers would be difficult. You would need new deployables, you need all this stuff. And sometimes there's maybe that natural friction and resistance to not wanting to develop those things because you as the developer are worried about the complexity that it's introducing. I feel like a superhero in a way now because as they're describing these things in the back of my head, I'm like, yeah, we could do that with like a workflow and okay, it'll be fine. Like it'll be okay. And then we just say yes. We're not talking about temporal to them. We just say yes. And I feel like we're saying yes a lot more. And I think that's really cool. This next use case, let me get a drink before this one. This is our most complex shaped workflow. That's another thing that's kind of interesting is the temporal adoption has been very organic inside Yum, and all the use cases are different, and the shapes of all the workflows are different. So it's not like we're just repeating one pattern over and over again. And this one, the use case is this. In our menu authoring system, you create a set of canonical products. Right? You define all their properties and what modifiers and stuff they can have and their names and their descriptions. Then you create a set of menus, which is just a collection of those products. And then you assign those to a store. And that's their menu that's going to get rendered if you go to pizzahut.com and select that particular store. These menus contain a subset. And why would you have different menus for Pizza Hut? And it's because one store might be like a sit-down Red Roof Pizza Hut, and another one might be like a delivery Pizza Hut that has less products. So you're gonna assign different sort of archetype menus maybe to these different stores. And at a high level, that's pretty simple. There's one extra layer of complexity that we have here, and it's that stores can introduce per store changes. So it's possible for a single store, say they have salad as a product, and we have that canonical product that everybody's using, but this particular store, this guy hates ranch. And I don't carry ranch in my store, I don't want it anywhere around me. So he'll patch out ranch, and he puts it inside of his per store changes, also per store pricing. So all these per store changes are there. So whenever people are then publishing menus inside our Yum admin system, this is kind of what it looks like here, where we'll kick off a publish job, and then you'll see the execution for each store as we're sort of constructing these menus. And if we wanted to support that use case I was just describing, this is how it might work at a high level, right? Somebody's going into our admin application, they're kicking off a publish job workflow. And whenever they do, we pull down their base menu definition and all the canonical products that are in it into a document. We then take each per store's changes and we apply it on top of that base menu, and then we assign these to the stores. So then they have their per store changes pulled from their base menu. And we also need to know the progress as this thing sort of advances. So, something you need to consider whenever you have these publish workflows is this. Imagine somebody goes into Yum Admin and publishes a menu that's assigned to 4 or 5 stores here, and then somebody comes in right behind them and publishes either a different subset of stores for that menu, and there's some overlap here. What do you do? The simplest thing you could do is just say that this works like a FIFO queue, and we're only going to do one publish job at a time. But that's not great. Our system is multi-tenant. Also, if somebody's making a tiny edit, they might not want to wait, minutes and minutes for a big publish job to go forward. So if we can, we would like both of these to execute. But what we don't want is if you just let them execute as quickly as they can, you have this problem where they might execute out of order, and then you might be rolling back what is actually a later change in the system. So we do not want that. We want them to execute in order at the store level. So this is what you actually want. You actually want a per store sort of FIFO queue. So that way, if you kick off this job and the next one comes, it's fine within that one store that has contention, they'll execute in order, but the other ones can go straight to the front and start executing. So if we were to build this, like this is what this workflow definition looks like, or this workflow looks like. This is how this works at Yum. And I am gonna show this part just really briefly and then throw it away. It's not super important, but we allow publishing multiple menus at once. I think for this talk, I'm just gonna focus on what does it mean if you're publishing one menu that's assigned to multiple stores at once. So that's just an extra level of indirection that we have, but it's not important. So the first thing that we need to do is we need to generate that base menu artifact. So we're gonna grab all the products that go into it and we're gonna shove this up into S3 or save it somewhere. We then need to signal to these entity workflows that we have that are per store. We're not kicking off these workflows as like a batch job that's like doing all of these. We have these semi-persistent entity workflows that represent each store. So we're gonna signal to the appropriate ones for the subset of stores that are executing. And we do signal with start because we do shut them down at the end. So if they aren't started, this will kick them off. So we don't have like 7,000 Taco Bells. We don't have 7,000 of these workflows active at all times. But while there's publish jobs going on, those stores will be active. Their workflows will be active. And then finally, the per store workflows are signaling back to this parent publish job. So that way we can have our fancy progress bars and stuff. And then once that job knows how many signals it should be waiting for. And then whenever it's done, it'll clean up its artifacts that it has, created for this publish job. So if we focus on what's happening on a per store level, it looks like this. Let's see, this is a little bit hard for me to read. Let me see, this is, okay, we're gonna create a publish job in the database. So we do this so that way we're not querying the signals across thousands of workflows. We wanna have a UI and admin that can show all the active publish jobs in the stores that it's active for. We're then going to get that base menu artifact out of S3 that all of these publish jobs share. So we get a lot of nice sharing here out of this and apply their per store changes. We are then gonna save that to S3. And then we're gonna update, I think, the store in the database. We're gonna publish an event that this store has a new menu. And then finally, we're gonna clean up that publish job, I think. So the thing that I wanted to show is that per store queuing is literally just an array in the workflow. And this, I think Max gave us this tip for doing this. And we get this per store FIFO queue just as an array in the workflow. And I thought that was super neat. So with this job will just in a loop continue to process publish jobs as long as it has any in that queue, and then whenever it's done, it shuts down the workflow. So that's that. I'm not gonna go into any lessons learned for this domain because one, we don't have time, and two, our friend Nils from Bitovi is gonna be giving a talk on synchronizing concurrent workflows, and I think he's gonna touch on some of the topics that we would likely touch on here. The next domain, let me get another drink. The next domain that we have is payments. And we have switched our payment system to do all settlements using temporal workflows. So the use case is very simple. We have a payment service internally that wraps the payment processors. And that's typically used like if orders are coming in, the order workflow is calling out to authorize payments or ultimately to do like a capture, or we have like admin applications that are initiating refunds for users for customer support. And what we used to have is something called a factory background job queue, which is it's kind of like Sidekick if people have used that, like a traditional background queue. And then we had these set of workers that were attached to it. So then any asynchronous settlement request for void or capture or any of those refund, we would enqueue and then they would work it and then they would make the appropriate call with the appropriate retries. And we outgrew this. So our scale hit a level where this sort of single, simple background queue, we were getting high latency in it no matter if it was tuned or not. And also all of that retry logic we had to sort of implement ourselves. So this is what we replaced it with. We now just have 4 workflows for our settlement types. We have a pool of settlement workers that work on them. And just like zooming in on one of these, it's just a really simple set of sequential steps that we have where, I think that we fetch the settlement request from the database. We fetch some keys for it. We execute the calling of the payment processor for this settlement. And that retry thing, this is where the retry is really important for us because payment processors will go down, but we will continue to retry with, we have appropriate back-offs and stuff, but for well over a day. So that's going on. And then finally, it's just kind of clean up and sending out events and things like that. So the main lesson that I think we want to call out for our payments use case is we have all of these workflows that we have that are sort of slightly different for payment, but if you look, the red ones are the only ones that are different between these, and we've been building up these other workflows with these sort of composable activities that we have. So this was the first use case in time that we've had where we've had sort of adjacent workflows that get the benefit of like reusing these components. So I just think that's neat. Okay, the cart use case. This is for cart abandonment. So if you put something in your cart, certain e-commerce platforms will reach out to the customer and let them know. Like, for example, Target's is really cool, I think, because they'll do it conditionally if the things in your cart are now cheaper. They're like, no, hey, you have the stuff in your cart and you can save money because it's cheaper now. Mass drop is another good example where these drops are available for a limited amount of time. So if you had previously added anything to your cart, it's about to not be available to buy anymore. So you might want to let the user know. So we had to implement this feature. The workflow design for this is this. At a very high level, it's just customers are interacting with the cart service, and we then are signaling to a workflow that has a timer. And whenever that timer is finally allowed to fully run, we will send out an event that the cart's been abandoned. And if we just sort of, this was our first pass at this workflow, where the cart service kicks off an abandonment workflow for every cart that gets created in the Yum platform. And we kick off an abandonment timer, and then we had signals for as people are touching the cart. If they touch the cart, we reset the timer, and then eventually that timer is going to run through its course whenever it's not been touched recently, and then we're going to publish the event. So this gets me into our lesson learned for this. This was a very expensive way to implement this feature. If we kind of look here, I'm going to call what I just described per cart workflow with push update. The signals and the pushes like of the new state is coming to it. This would burn about 380 million actions for us at just our current scale. And we're about to bring on Pizza Hut and it would be even higher. And just for context, that's roughly about the number of actions that we have for our order workflows, like just for executing them. So this ancillary feature that we have, we don't want it to take up as many actions as our order workflows or cost the same amount. It's not worth the same amount of value to us. So we looked at, okay, what can we tweak with this workflow to get the actions down? So if that was our old one, this is the new one. And it's very similar. We kick off the cart abandonment workflow. We have our abandonment timer, but we remove those signals. And we just let this abandonment timer run to its conclusion every time. So if our abandonment time is 45 minutes, this is going to run to 45 minutes. Whenever it fires, this activity now will check the cart service and see if it's been touched. And if it has, then it'll reset the timer for the appropriate amount of time. But if it hasn't, then we're going to send the event. This reduces all the churn as people are adding multiple products to their cart. Like before, we were, getting perfect granularity as we signal to this workflow for every single taco people are adding to their cart. That's no longer the case. Now we just run out for the 45 minutes, and most of the time, by 45 minutes, people have stopped touching their cart, and there's no more churn. So I'm going to call this option per cart workflow with pull update. And this was about a 5x reduction in our action spend for this use case. That's really great. There's a third option that we're considering, but I don't know if we're going to do. And this is maybe how we would have traditionally done this, pre-temporal, I think. And I think it's still fine, and we're still using temporal to do this. But instead of having per cart workflows, instead we would have a global workflow, and we would push more work of state management into the service in the cart database, where we would store last touch time and whether or not this event had been sent out alongside the cart. Then we're going to have probably use workflow scheduling to, for every 5 minutes, kick off this global workflow, which will then query the database for carts which have now sort of exceeded this threshold, mark them in the database as having sent the event, and then we'll send the event. The napkin math for this one shows that it's probably another 4x reduction for us. So we might do this, but actually we like option 2 a lot because there's other use cases we might want to hang off of per cart things. So we're considering staying in the option 2, but I just wanted to kind of highlight the cost reductions here. So I'm just going to show a really quick 1-minute video of an order executing. So if you remember, I walked through all the steps of the order. The point of this video is for you to not necessarily be able to easily follow along the step that it's on. The point is that this is playing in near real time for the workflow execution. And I also want to warn people that I am terrible at making videos. And I think getting this stupid red arrow to move in Adobe Premiere was probably harder than anything I've done in Temporal easily. Okay, so we have my friend Robbie. He's placing a Taco Bell order on the mobile app. We've not yet initiated the order workflow. He's adding his items. He's kicking off the order now. Now we're saving it to the database, authorizing the payment, and now we're waiting for that order to get down into the store. So it's getting down the store. We just got confirmation that it's down in the store. So now we're waiting to hear when the store is going to start working on the food, when they're committing to working on it. So, that's the employee in the store committing to making the food, and that's going to show up sort of on the pack screens and on the KDS screens. So you'll see it there. I didn't have a video of them preparing the food, so. Now they've said that they've completed making the food, so then we are saying this food is ready. So it's ready, and now we're just waiting for somebody to come and pick up the food so we can do the fulfill signal. So somebody comes and grabs it through the drive-thru, and we'll advance through those. And now we're in these sort of automatic transactions here where we're going to capture the payment, we're going to send out our final event. And then if you were to go to like the Taco Bell app, you would sort of see a finalized order that's been paid. So that's it. The only other thing that I want to say is the people that have made all the stuff that I've just said are on the screen here. I did not make any of this, and they're amazing. And most of them are here today. So this is their names. And if you see them and you're interested in one of these use cases that I walked through, please grab them and talk to them about it. I think they'd be very interested to hear both feedback or provide any advice related to their use case. So that's it. Thank you.
Want to stick up? Let's see if there's any questions. We've got about 5 minutes for questions, and we're happy to take some. I have one question, Matt. Is there like a local Taco Bell where you walk in and like, can I like film you making food?
Yeah, there definitely is. There's some friendly equity stores that we do weird stuff in.
Okay, that's good. I was just like, if you walked in, I'd be like, what's with this guy? Is there any questions? Does anybody have any burning questions? So something simple, something hard. No? Oh, good. It's hard for us to see. Oh, we have about 5 minutes. Great. There's here.
This is not very technical, but can you bring back the Mexican?
Yes, I will pass that request on. We just got the Mexican pizza back though, so.
Wow, no KFC questions, but it's cool. There was one over here too as well? Oh, all the way over. Sorry, Irina. Thank you, Irina. I think it's all the way at the very far end. I'll repeat it.
Okay.
If you just yell it, we can repeat it as well.
Okay. You have all of these diverse brands. How do you share code, or do you share code between your engineering teams? Do you build libraries and then everybody uses those, or some common patterns like maybe payments?
Yeah. So Matt, just before we start, just for video, so if people are watching this later, you have all these disparate brands and disparate teams. How do you share code? How does this kind of work within the various different groups?
That's a great question. This is a multi-tenant platform, and the brands are intended to come on to this same platform. So we share code just by virtue of them being executed sort of on top of the same platform. Now, different brands in different countries might have different payment providers and things like that, but our services are intended to appropriately switch to the sort of market-specific payment processor, for example, or the market-specific endpoints for transmitting order down into the store for that specific point of sale, things like that.
Matt, how long has it taken for you to get like the central commerce platform to be adopted across because I mean, each brand is kind of its own group, right?
Yeah. Each one is a pretty large migration project. I probably took KFC coming on board as we were building the platform about a year, maybe like another year for Taco Bell, and now Pizza Hut. We're hoping to have pieces of it carved off by the end of this year, but it's going to go into next year for sure.
Right on. I'm not going to ask you which code base is the best or the most. We won't put the teams on. Thank you, Matt. I don't know. Was there? Oh, there's one more here. Yeah. Great.
Hi, Matt. Have you experienced any latencies by using Temporal? It's essentially another layer, right? Mm-hmm. Sometimes you have user-facing services. How do you deal with that situation?
That's a good question. That was on the mic, so we're good. The place where we're most latency sensitive is in the order use case during those first set of activities that are automatically executing, because the brands on their websites typically are showing like some kind of loading screen, and then until the order is like a real thing in our system, only then do they advance to like the confirmation final screen. So we are latency sensitive to that, and that's something that I think we can always improve, is driving down the time for that. After that point, it's all asynchronous and it's okay. We're not very latency sensitive. I'll say payment settlements, for example, with our old background queue that we used to use at peak time. So if we're talking a very busy promotional day, it would take something like 20 or 30 seconds of latency that got introduced from our background queue just for processing the settlements. And they're all sub-second now, and going through all those steps. So it's actually been a huge win for us from a latency perspective, other than that one case where we need to get through a bunch of really quick activities.
Cool. And I think one more question.
Hey Matt, good question. As you went through this modernization process, have you seen use of event-driven queuing systems go down in your organization?
Yeah, I think so. We used to use SNS SQS in our platform. We now use Kafka internally, but it actually doesn't really drive much behavior inside our platform. So whenever you saw all those activities that were like event activities, those are actually just for us to emit a Kafka event, and then they go to a webhook dispatch system, because then the brands are subscribed to these webhooks. So that's one of the few things that we use like Kafka or an event system for anymore.
Cool. And I think one more question. We had a troublemaker up front. This guy by the name of Rajesh.
Okay. Sorry. Hey, Matt. One question. So with the new features that Temporal has released, especially the workflow update,
yes.
Do you see yourself moving from signals to doing workflow updates?
Literally the second they activate it for our system, we're going to switch. We were texting each other about it. Yes. Especially for those order signals that are coming in, because those are synchronous operations for us, where we return the status of the update. So we kind of do that in an awkward way today. Workflow update's going to be great for that.
Yeah. It was funny when we were building Samar's keynote, we were talking about this whole activity and setting these Booleans and all this stuff. I'm like, don't worry about it, Samar, because Matt's going to actually show that. You know what I mean? So yeah, it replaces all that kind of activity. So cool. Thanks, Matt.
Awesome.
I really appreciate it.
Thank you, everyone.